So, to go from mole to mass, it's a little different from going from mole to mole. So, first what you're going to do is we are going to read our question. If 14 moles of potassium oxide reacts with an excess amount of magnesium nitride, how many grams of potassium nitride will be made? So first we want to check and make sure that we're actually going from mole to mass in this problem. So we're starting with moles, which is what we start with here, and then we're ending with grams, which is what is considered our mass. So using this equation, we want to make sure that we have the same compounds that are included in our question. So we have potassium oxide, which is right here, and then we have magnesium nitride, which is right here. We have our products, which are magnesium oxide, and then we're looking for how many grams of potassium nitride will be made. So this is going to be our ending, and it's going to be in grams, and our given will be potassium oxide, and we're going to start with 14 moles. Before we can actually get working on our stoichiometry problem, we want to make sure we have a balanced equation to make sure that our mole-to-mole ratio will be right for our problem. So first, let's check with each individual element and make sure we have the same amount on this side as we do this side. So magnesium, we have 3 over here, and we only have 1 over here. So we already know that we're going to have to add a 3 right here. Now you also can go and check, because I'm already noticing, as I move to my next element, I have 2 here for nitride and only 1 here. Thankfully, I don't have to rewrite this because it's still correct, but sometimes chemical equations are always just guess and check. So you might write, or balancing chemical equations are always guess and check. So you might write something and then have to mark it out because another element of that compound needs something else. But thankfully we don't in this case. So to get our 2 nitrogens as we have on this side, we're just going to put a 2 here. Now we're going to look at here we're going to go to oxygen first because I know that already this oxygen isn't going to be the same since we just changed it here. Well, we have 3 over here, so we're going to put 3 here, which also helps make our potassium right. So we have 6 potassium now on this side and 6 potassium now on this side. So our chemical equation is balanced. So now we can move on to our first step. So we're going to take, the first step we're going to do is we're going to take our 14 moles of potassium oxide. So we have 14 moles of potassium oxide. That's our given, so that's how we're going to start. Now, our ending is going to be potassium nitride, and it's going to be grams. So we can already put grams of potassium nitride. Now, what we're going to do is, since we're already in moles, we don't want to change this, do anything to this to make it grams, but we can go ahead and go straight to our mole-to-mole ratio, which is going to put mole of K2O down here, and then we're going to K3N. So this one's going to be on top. Well, let's now check. Oh, forgot moles. Now let's check and see how many of K3N we have per K2O. So for K2O, we put a 3 in front, so we're going to put 3 moles, and then there's a 2 for potassium nitride. So now we have our mole-to-mole ratio, but now we have to convert our moles to grams since we're going from mole to mass and we want to end up with our mass. So for K3N, the way we're going to figure out is we have to get our molar mass. So for however many, it's going to be for 1 mole of K3N, we have to figure out how many grams that is. So it's basically, like I said, our molar mass. And the way we're going to do that is we're going to use our periodic table, and we are going to find the atomic mass of potassium and the atomic mass of nitrogen and add those together to get our molar mass. So for potassium, we have a molar mass of 39.1. So we're going to do 39.1, and the reason I put parentheses is because we're going to have to multiply it by 3 since there are 3 potassiums. So times 3. then it's going to be added to our our atomic mass of nitrogen. And nitrogen is 14. So we're going to add those together and we're going to get 131.3. And that is how many grams we have of potassium nitride per 1 mole of potassium nitride. So that's our molar mass. Now, to find what the question is asking, all we're going to do is we're going to multiply the top numbers. So 14, 2, and 131.3. And then we're going to divide those by 3 and 1. And the way we're going to do that is we're going to put parentheses so that we make sure the multiplication is happening first. And there we go. Now we can see them both. So we're going to do 14 times 2 times 131.3, close parentheses, divided by, and since we only are really dividing by one thing, by one number, just the 3, since the 1 will give us the same answer either way. So we're going to do divided by 3, and we will get 1,225 point, we're going to round up the 4 using the 6 and make it the 5. So it's going to be 1,225.5 grams of potassium nitride. And that will be your final answer.